Hey everybody, Mr. Piercy here, and what we're going to be looking at in this lesson, in this video, we're going to be talking about a segment of a triangle called a median. Now, a median is a segment of a triangle that goes from the vertex of the triangle to the midpoint of the side across from it. So the first thing I'm going to do, so that way I can actually get my medians on my triangle, is I'm going to construct the midpoints for this particular triangle. Now, the median of the triangles are going to, as we've seen in other lessons, they are also going to create a point of concurrency. The point of concurrency that we're going to be finding here has a lot of math characteristics about it that I want to show you. There's very definite relationships to the length of the segments of a median that we're going to be using in our class. So just give me one more quick moment here so that way I can have my midpoints identified. So here's one midpoint. Here's a midpoint. And here is a midpoint. So the definition of a median is that it goes from a vertex of a triangle to the midpoint of the opposite side. So we're going to have three medians. They look like that. And you can see that they have a point of concurrency. So here I'm going to call this midpoint D, this one E, and this one F. And I'm going to call this point C. This point here that I'm calling C this is called the centroid of the triangle. It sounds kind of like a weird name, but you can tell by the prefix of the word centroid or cent that, and based on kind of where it looks, that the centroid is actually the center of the triangle. So it's not going to have, it's not going to be the center of a circle the way the circumcenter and incenter are, but it will be the center of a circle, sorry, not the center of a circle, but the center of a triangle. Now, what I wanted to show you here is there's some very specific characteristics that I want you to see. So looking here, I'm looking at segment CE, which is the small portion of the median, because you can see the median, LE, has been broken up into two separate segments here. I have part LC and I have part CE. Well, looking here at CE, I can say, well, here is another length of CE, and here is another length of CE. So what I can see, what I can conclude by looking at that is that CE is 1/3 of the whole length, LE. And because I was able to take one of these and put two of them here, I can now say that I could say that LC is equal to 2 of CE. Or we could write it the other way around, and I can say that CE is half of LE. Oops, LE. And I could take this one and I could turn it around, and I could say I can make 3 CEs to equal 1 LE. So we can see that there's a variety of ways that we could write these relationships, where we have out of the entire median, we have it broken up into two pieces. I have a big piece, LC, and I have a small piece, CE. So the only other thing that we can say is, how does LC compare to the whole thing? Well, LC, the big piece of the median, if the little piece is a third of it, then the big piece must be two-thirds of it. So I would say LC in this case is going to be two-thirds of LE. And those are some very interesting characteristics about the centroid of a triangle, or the medians of a triangle. And these will be things that will be tested in your assignments, in your quizzes, and in your tests. So I just wanted to show you why, again, I don't want to just say, hey, this is what it is, trust me because I'm the teacher. I want you to see this is why. It's not like people just made this stuff up. Based off of observations, we can conclude certain things. Now this one here was specifically made to be an acute triangle. So here I wanted to show you what it looks like for a right triangle. It looks pretty similar. The centroid is going to be inside of the triangle again. If it has to be the center of the triangle, it must be inside of the triangle. And for an obtuse triangle, again, same thing, the centroid must be inside of the triangle. It doesn't matter what type of triangle it is. If it's the center of the triangle, it has to be inside of it. So those are some unique characteristics about medians of a triangle. So just big ideas. Remember, median is a segment that goes from the vertex to the midpoint of the side across from it. The point of concurrency of the medians is called the centroid, which is the center of the triangle. And the lengths of the segments of the median are broken up into very specific ways, showing that the small piece is a third of the whole thing, the big piece is two-thirds of the whole thing, and that the big piece is twice as long as the small piece. So that's all that I'm going to talk about here for medians. We'll go into more detail into the notes that you're going to see for your lessons. But until next time, guys,